Hello students! So this video here is solving quadratic equations using the quadratic formula, part 2. In that last video we just gave you a little bit of background information about what to expect when you're trying to use the quadratic formula. In this video we are going to be working out some examples that will show you exactly how to do what we discussed in part 1 in the first video. So let's say we were looking at this example here where we were asked to solve this. Of course this video is using the quadratic formula, so it goes without saying that you're solving it using the quadratic formula. And so remember that the first thing that we need to do if we're using the quadratic formula is we need to make sure that our equation is set equal to 0, and we need to make sure that the expression is in standard form. Right now this expression is not in standard form. Remember, standard form for a quadratic expression, or even for a quadratic equation, is ax squared plus bx plus c. And right now, these terms are not in the right order. They've got to be ordered so the highest exponent, where the highest exponents come first, and it goes down to the lowest exponents. So it should be x squared. The x term should be in the middle, and then the constant term should be the last one. So all we really have to do here is just rearrange the order of these three. We keep the signs, so in other words, the sign for this 4 is negative. We keep that sign for the 4 the same. It was negative 4 written there. It's still going to be negative 4x when you write it here in the middle. This 3 was positive 3. It's still going to be positive 3 when I switch the order of it here on the same side of the equal sign. We didn't have to use any inverse operations. All we did there was use the commutative property, which says that we can switch the order of addition. Okay, and that's what we did. So we switched that order there. Everything, whatever the sign was for that particular term, it stayed the same. Okay, so now we do have it in the right order. It's in standard form and it's set equal to 0. Next, what we need to do next we will identify A, B, and C. So again, the form that this is in right now is that standard form, ax squared plus bx plus c equals 0. And so in this form, we should be able to easily identify what A is. A is the coefficient for x squared, which is 1. B is the coefficient for x, which is negative 4. And C is that constant term here, 3. So after we've identified A, B, and C, what we need to do is we need to find our discriminant. Remember, folks, that the discriminant is b squared minus 4ac. So again, when we calculate that discriminant, the b squared minus 4ac, we do it like this. And for those who don't have like a graphing calculator with them, again, you've got your cell phone possibly. Remember that your cell phone, or at least most smart cell phones, and most people do have at least smartphones. Most smartphones have an option on your calculator phone, on your phone calculator, like that when you turn it sideways and it flips to that side view, it goes automatically to a what is it? Scientific calculator. And so again, so if you're doing that discriminant, b squared minus 4 times a times c, when you are calculating this part here, here's my suggestion for you. especially for those who may not be so who may not do so well with calculating certain things. Because I'd really hate for you to have the right formula and then you get it wrong because you get the calculation wrong. Even with the calculator, I've seen people get the calculation wrong. I'd really hate for that to happen. So here's my suggestion to help you out, to help everybody out with the calculator part. Whether you got a graphing calculator or just a regular old Joe Smo calculator, scientific version. My suggestion is to go ahead on and calculate the b squared. Now, you see how I've got this in parentheses? Guess what, folks? If you don't put this -4 in parentheses, if you're trying to use a calculator and you don't put this -4 in parentheses, so again, if you were doing something like, and I'm going to erase this afterwards, but if you're doing something like this in the calculator without parentheses, guess what? Your calculator is going to say 4 squared, and it is going to multiply that 4 squared times -1. But guys, if you put parentheses around the -4, when you square it, your calculator is going to do it the right way. And your calculator is going to multiply -4 times itself. It's going to multiply the whole quantity of -4 times -4. I don't know how much you remember about order of operations, guys, but the way that it's written without parentheses says that you need to square the number 4, and then you need to multiply that times -1. So there's a reason why I've got this number in parentheses here. For those who are wondering, it is important for you to put parentheses around that, especially if you don't remember that squaring a number is multiplying it times itself. Okay, so again, that's multiplying -4 times -4, which does give you 16. All right, so once you've got that, what you need to do is you need to actually multiply. So my suggestion is you need to multiply all 3 of these numbers together. Multiply -4 times 1 times 3, and keep whatever sign that is. And so you see I've written this as addition, but I've kept the 4 as a negative. Okay, so you need to multiply those 3 numbers together. I'm trying to help you out because I've seen people get the calculations wrong. Even when they're using a graphing calculator, I've seen people get the calculations wrong. So I'm trying to help everybody out here, whether you got a scientific or graphing calculator, so that you can get the calculating part right, even if you do have the formula right in front of you. All right, so this is -4 times 1 times 3. That gives you -12. So this winds up being 16. You can either say plus -12, or you can say just 16 minus 12. So again, I'm just showing you this calculating part. Because again, I'd hate to see somebody get the problem wrong because you put it in your calculator the wrong way, or you just didn't know how to calculate it. 16 minus 12 equals 4. So our discriminant here is 4. Alright, so after you calculate your discriminant, what we need to do next is we need to go ahead on and calculate what negative b is. Calculate what negative b is, and also calculate what 2a is. Also, just kind of be mindful that in the first part, or in part 1, in that first video that we did on quadratic formula, we mentioned that based on what your discriminant is, the discriminant can determine how many solutions you're going to have and what type of solutions those are going to be. So remember, in the last video we said that if your discriminant was a positive number, that means you're going to have 2 real solutions, 2 real numbers as your solutions. All right, but again, next we need to calculate the the negative b and the 2a. And remember, we said that negative b is really the opposite of b. So when we're calculating that negative b, again, let's go ahead on and multiply, or in other words, if b is negative 4, right? So b is negative 4, and we said that again, a lot of people might call this negative b. However, folks, we have discussed this in part 1 of this video. This is not negative b. Even though it may look like that's what it says, what this is the opposite of b. So again, please don't get it confused. In other words, it's the opposite sign of b. So since b is negative 4, we use the opposite sign of b. So whatever b is, since b is negative 4, it's like we're going to take the opposite sign of it. That's what happens when you got that negative in front of it. It's the opposite. You're doing the opposite sign of negative 4. And so it's like you're multiplying negative 1 times b. Because technically that's the coefficient. Negative 1. Alright, and so the opposite of that is 4. That should be pretty self-explanatory there. And then, folks, what we need to do after we have calculated the opposite of b is we need to go ahead on and calculate the 2a. And again, that is where we multiply 2 times the value of a. So when we're calculating 2a, again, we're multiplying 2 times a. So here we are multiplying 2 times 1. Alright, and that is 2. So now that we've got these 3 parts, next we need to substitute those calculations, those 3 calculations, the discriminant, the opposite of b, and the 2a. We need to substitute those calculations into the quadratic formula. Folks, remember that the quadratic formula is this here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b plus or minus square root of b squared minus 4ac all over 2a. So again, we will substitute those parts that we just now got. We're going to substitute those into the quadratic formula. And that should be, the wording there should be pretty self-explanatory. Where you see negative b in the formula, where you see that part in the formula, you're going to put positive 4 there and replace it. Where you see the b squared minus 4ac in the formula, that is the discriminant. You're going to replace that part with oops, sorry, I said that wrong. Well, no, I didn't. You're going to replace that part with the discriminant 4. And where am I at? Yeah. And this part here. Sorry, I got a little distracted. And this part here, you're going to replace with the 2a that we just calculated. You're going to replace that with 2. So again, you're going to replace those parts there. So here, x equals the opposite of b, which we determined was 4. So x equals 4 plus or minus the square root of the discriminant, which is the part or the number up under the square root, the radicand. We determined that that was 4. So the square root of 4 there, and then it's all over 2a, and we determined that 2a, the calculation there was 2. So after we have replaced or substituted those parts into the quadratic formula, what we need to do next is we need to simplify if possible. So what does that mean? First off, if your radicand or if your discriminant was a perfect square, then of course you need to actually, simplify the square root of that perfect square. In this case, our radicand or discriminant 4 is a perfect square. So when we take the square root of 4 here, when we simplify that, clearly the square root of 4 is the same thing as 2. And so in this case, that's what we need to do. In other cases, when we're talking about simplifying this, we may need to write it in its simplest radical form. Or for instance, if it was going to be an imaginary number, we might have to simplify it and write it in its imaginary form. But anyway, in this case, we're going to take the square root of 4. So again, here we're going to take the square root of that perfect square discriminant. And so again, we're going to take the square root of 4, and when we do that, what we have is 4 plus or minus, and again, the square root of 4 is 2, so we write it like that, and we've got 4 plus or minus 2 all over 2. Now, so we have simplified that square root part of it, but this can be simplified even further. Remember, guys, that plus or minus, that means that we have two separate answers. So I'm going to write it out like this. Because when we've got it written like this, and these are just like these are all rational numbers. None of these numbers are irrational, and I know we didn't necessarily talk about irrational numbers in just yet, but again, yeah. All right, so this expression here is written fairly simple. It doesn't have a square root in it anymore, so we can actually simplify further. So again, remember that plus or minus, it indicates that there are two versions of this answer. One version has a plus, the other version has a minus in it. So in one version of this, at the top, you are going to add 4 plus 2. And in the other version of this, at the top, you're going to subtract 2 from 4. So the way to simplify these two fractions, and again, please pay attention to my placement of the parentheses. Okay? So what you are going to do first is you are going to, again, for this part here on the left, you're going to simplify the top of the fraction, simplify the numerator first. So you're going to do 4 plus 2. I'm explaining exactly how you need to do it, with or without a calculator. It doesn't matter, because if you listen to what I'm saying right now, you will be doing it the right way. 4 plus 2 is 6. And you divide that by 2. Okay, if you can't figure out what 6 divided by 2 is, we got a problem. Okay? Alright, so 6 divided by 2 is clearly 3. Alright, and then for the other version of it, you simplify the top of this fraction, the numerator of it first. And 4 minus 2 is 2. So the top simplifies to give you 2. And so that's 2 divided by 2. And again, 2 divided by 2 is 1. So here we have two distinct and unique answers. And again, the two answers came from the fact that that again we've got the plus or minus symbol. Okay, so that plus or minus lets us know that we need to split this up. Alright, so those are our two answers. So again here, folks, these two solutions that we have are two real solutions because the discriminant was positive. Okay, so let's say that we were looking at this example here. And so when we look at this, remember the first thing is making sure that the equation is equal to 0 and making sure that it's in standard form. And so it is. So it's already equal to 0 and in standard form. So what we need to do is we need to go ahead on and identify our A, B, and C. Okay, so this equation is already in standard form. It's ax squared plus bx plus c equals 0. It's already in the exact form that we needed to be in. We're identifying a, b, and c. So in this form, a equals 2, coefficient, that's the coefficient for x squared, b equals 2, and c equals -1. So now that we've got our A, B, and C, we need to go ahead on and calculate our discriminant and calculate the opposite of B, even though it may look like negative B. Remember, we're calculating the opposite of B. And we need to go ahead on and calculate 2A, 2 times A. Alright, so let's do this. Let's calculate these three parts. The discriminant is b squared minus 4ac, b squared minus 4ac, and again, I've tried to show you the right way to do this so that your calculation comes out correct. Again, b is 2. If we go ahead on and square that, b squared 2 squared, or 2 times 2 gives us that. Then if we will just kind of write this part out as multiplying 4 times 2 times -1. And again, if we'll, so first you'll square the b, then if you will multiply -4, multiply -4 times 2 times -1. Alright, so when we do that, we get +8. So we wind up getting here 4 plus 8 for the discriminant, which is 12. So our discriminant here is 12. I'm going to shorthand that. I'm going to write DISC for discriminant. Okay. Alright, so we've got our discriminant, and let's do the opposite of b here. So the opposite of b, again, it's like we're multiplying -1 times b, so that's -2, and then 2a is us multiplying a times 2, or in this case 2 times 2, which gives us 4. So we've identified those three parts. Next, what we want to do is we want to substitute those three parts into your quadratic formula equation. And again, so here, when we substitute in those calculations, the discriminant, the opposite of b, and 2a, when we substitute those into the quadratic formula, it winds up looking like this. X equals, again, for the opposite of b, we got that is -2. And then this is plus or minus the square root of, and we said that discriminant, or the radicand, the part that's up under the square root, we got 8 for that. And that's all over the 2 times a, which we got 4. Alright, so from there, what we want to do is we want to go ahead on and see if we can simplify this. And here, it is possible to simplify this, even though we can't take the square root of, or I'll put it like this: the square root, this number here, this discriminant or radicand 8 is not a perfect square. However, we can write this radical as or we can write this radical in its simplest radical form. And guys, most of the time, whether or not they ask you to write a radical in its simplest radical form or not, if it can be done, you should go ahead on and do it. And so if you're, like I said, if you're not sure whether it can be done or not, just take a look at that video that I showed you about simplifying radicals in their simplest form. And I believe that was one of the videos that I made for the solving quadratic equations by using square roots. So if I'm not mistaken, I had that in part 1 of that, the solving quadratic equations using square roots. But you can look again at how to write or rewrite radicals in its simplest form. So again, here we're going to write the square root of 8 in its simplest form. And so we're going to go ahead on and break that down. Remember when we were doing this, and we talked about that, we said you should think of factors of 8 that include perfect squares. Well, 8 only has 4 factors. The number 8 only has 4 factors, and the only factor of 8 that is a perfect square is 4. Right? So we need to choose that pair of factors that has that perfect square. So that pair of factors would be 4 and 2, right? So when we split 8 up into factors, where one of those factors is a perfect square, this is the pair here. The square root of 4 times the square root of 2. So the square root of 4, again, 4 is a perfect square, that can be simplified, which can be simplified to 2. So the square root of 4 is 2. And we're just going to bring down the square root of 2 here, because that cannot be simplified. So the square root of 8 written in its simplest radical form is 2 times the square root of 2. And so that's how we're going to write it here. So we're going to write it as, we're going to write this all out. Plus or minus plus or minus 2 times the square root of 2 all over, and in this case we have 4. Alright, so we are still not done here as far as the simplifying part. So if you do have any, so after you simplified this way, if you do have any fractions that can be simplified, then you do need to simplify those fractions. So first off, the way that I'm going to write this as of right now is I'm going to write this as two separate fractions, and not I don't want to confuse anybody, but I'm going to write this as 2 separate fractions, and then we're going to see if we can simplify each fraction. Alright, and actually I really don't have to write it like that, not like that, not quite like that. But I'm going to split this up into 2 separate terms. Maybe that's a better way to put it. So guys, when you have 2 different terms at the top, right? So at the top we've got the -2, and you see that these terms are separated by a plus or minus sign, literally a plus or minus sign. And so when you do have 2 terms at the top of a fraction in the numerator at the top of a fraction, then you can split it up, or put it like this: when you've got 2 terms at the top and you've only got 1 term at the bottom, and that term is a constant like 4, then you can split it up into separate fractions. So that's what we're going to do here. So we're going to write this first fraction, -2 over 4. All right, and the second fraction, plus or minus, right? The second fraction is going to be 2 times the square root of 2 over 4. So again, we can split this into 2 separate fractions because we got multiple terms at the top, and we only have 1 term at the bottom, which is a constant term. And so again, this is the same thing as writing this as 2 separate fractions with the same number at the bottom, with the same denominator. And and for anybody who actually remembers how to add fractions or subtract fractions with the same denominator, then you already know that this is true. But anyway, so once we've written it like this, then we can simplify those fractions. So again, -2 over 4 can be simplified in both of these fractions, and then 2 over 4 of course can be simplified. If you don't remember how to simplify fractions, that's a whole nother conversation, but I will try to do a little reminder for you here.